All right, here's part 2 of day 1 notes for 2.5. We're going to graph rational functions still. So vertical asymptotes, we talked about the vertical asymptotes occur when the denominator is 0. The horizontal asymptote, so here's the rule. If n is less than m, the horizontal asymptotes is y equals 0. So first of all, what is n and m? So going back and looking at this guy, n is the degree of your numerator. So for this one, n would be 2. M is the degree of your denominator. So for this example, m would be 1. So what this is saying is, if n is less than m, so the degree of your numerator is less than the degree of your denominator, then your horizontal asymptote is y equals 0. If, like we had up here in b, the degree of my numerator is bigger than the degree of my denominator, there's no horizontal asymptote. And if the degree of the numerator is exactly equal to the degree of the denominator, the horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator. All right. The other thing we're going to look for is we're going to try to find our x-intercepts. Remember, that occurs wherever your y is equal to 0, and then find your y-intercept that occurs wherever your x is equal to 0. We're going to use these points and the asymptotes to start sketching graphs. We may have to find other points along the way. So let's look at example number 2, chart A. My vertical asymptote, we talked about this, would be x equals -3. Because that's what makes my denominator 0. My horizontal asymptote, the degree of my numerator, is 0. Remember, this is times x to the 0 power because x to the 0 is 1. But we don't write x to the 0 power. And then the degree of my denominator is x to the first power. So n is less than m, which according to our rules here, if n is less than m, my horizontal asymptote is y equals 0. All right. For my x-intercepts, that's when y is equal to 0. This guy here is my y. So I'm going to set g of x equal to 0. When I solve this guy, I'm going to multiply times x plus 3. So I get the equation 0 is equal to 6. Is that ever true? Nope, not true, so we have no x-intercepts. All right, to find y-intercepts, that's when x is equal to 0. So I'm going to plug 0 into my function, and I get 6 divided by 0 plus 3. 6 divided by 3, that's 2. So my y-intercept, x is 0, y is 2. All right, so let's use that information to graph this guy. So we know we have a vertical asymptote at -3. I have a horizontal asymptote at y equals 0. I don't have any x-intercepts, but I know I have a y-intercept at 0, 2. So I know I have a piece of the graph up here that's going to hug those asymptotes, but go through that y-intercept. For my algebra 2 understanding, I know this is a reciprocal function, so I think the other half is going to be down here, but let's go ahead and test a point. So if I want to test a point, I'm going to ask myself, if I'm less than -3, I'm on this side of the asymptote, what number could I choose? If this is -3, let's try -4, and I'm going to plug that into my function. And if I get a positive y value, then that means this is where I would draw the graph. And if I get a negative value, that means this is where I would draw the graph. So plugging in that -4, I get 6 divided by -4 plus 3. That's 6 divided by -1, which is -6. So indeed, we are down here when x is -4, y is a negative value, so we're down here. All right, that's it for A. Looking at B. All right, my vertical asymptote, what's the one thing x can't be? X can't be 3, so I have a vertical asymptote at 3. For my horizontal asymptote, the degree of my numerator is 2. The degree of my denominator is 1. This time n is bigger than m, so there is no horizontal asymptote. All right, looking for my x-intercepts. That's when x squared minus 7x plus 10 is equal to 0. And here I multiply by x minus 3, and this times x minus 3. So I just get x squared minus 7x plus 10 is equal to 0. You're going to start to see that with these rational functions, it really just matters with what on top is equal to 0, because this guy is always going to be multiplied times 0, and I end up with the numerator is equal to 0 every time. So if you want to skip this step, by all means, you don't have to write that. You could just show me this, and I'd be okay. This is a quadratic. I'm going to solve it by factoring. So that'd be x minus 5, x minus 2, negative 5 times negative 2 is 10, negative 5 minus 2 is negative 7, which means x is equal to 5 and x is equal to 2. So my x-intercepts are 5, 0, 2, 0. For my y-intercept, I'm going to plug in 0. When I plug in 0, this becomes 0, 0, and 0, and I just have 10 divided by negative 3, which means my y-intercept is 0, negative 3 and a third, or negative 3.3. All right, graphing this, my vertical asymptote, I've got 1 at x equals 3. I don't have a vertical or a horizontal asymptote. I've got an x-intercept at 5, 0, and at 2, 0. I also have my y-intercept, which is 0, negative 3 and a third. Put you down here. So having 2 points, I know that the graph is going to look something like this. On this side, though, I don't know, is it going to go like this, or is it going to be hugging the asymptote and then flare out like that? So in order to find that, I need another point to help me graph it. It's kind of like when you're graphing a line, you have to have 2 points in order to know how to graph it. All right, so let's pick something. Anything bigger than 3. I could choose 4, I could choose 6. Let's just do 4 for fun. So I'm plugging it into my k function up here. So 4 squared is 16, minus 7 times 4 is 28, plus 10. On the bottom, I've got 4 minus 3. So this would be 16 plus 10 is 26, minus 28 is negative 2. 4 minus 3 is 1, so I've got the point 4, negative 2. Really, I just want to know, is it positive or negative? But here's 4, negative 2. I have to be terribly precise with it. If you just showed me something like this, I'd be okay. All right, moving on to the u-tries. For A, I'm going to have to factor out this denominator in order to figure out where my vertical asymptotes are. So 3 plus 3 minus 1 would be my correct factorization there, which means my vertical asymptotes occur at x equals negative 3 and x equals 1. For my horizontal asymptote, my numerator, degree of numerator is 0, degree of my denominator is 2. N is less than m, so my horizontal asymptote is going to be at y equals 0. For my x-intercept, that's when this guy is equal to 0 or when the numerator is equal to 0. That never happens, so we don't have any x-intercepts. And then for my y-intercepts, that's when I'm plugging 0 in for x. So that would be h of 0. So that's 2 over 0 squared plus 2 times 0 minus 3, or negative 2/3. All right, let's graph this guy. We've got a vertical asymptote at negative 3 and at 1. I don't have it. Oh, we've got a horizontal asymptote at 0. I don't have an x-intercept, but I do have a y-intercept at negative 2/3. So 0, negative 2/3 would be somewhere down here. Since it doesn't cross the x-axis because I don't have an x-intercept, I know it's going to go down on both sides and get close to its asymptotes without touching. And then I just need a test. Is it going here and here, or here and here, or here and here, or here and here? So let's test something that's less than -3. Is it up here or down here? So let's do h of -4. That would be 2 over -4 squared would be 16. -4 times 2 is -8 minus 3. So this would be 2 over 16 minus 8 minus 3 over 2. So it's positive, which means we're going to be up here. And then let's pick something bigger than 1. Let's do 2. So h of 2 would be 2 over 2 squared is 4, plus 2 times 2 is 4 minus 3. So this would be 2 over 8 minus 3 is 5. So 2/5, it is also positive right here. All right, let's see if we can get one more on this video. So again, we're going to factor out this denominator. This will be x plus 2, x minus 1. My vertical asymptote is whatever makes this 0. So x equals -2, x equals 1. My horizontal asymptote, the degree of my numerator is 1, the degree of my denominator is 2, n is less than m, so I have a horizontal asymptote of y equals 0. My x-intercept, that's when my numerator is equal to 0, so in this case it's just when x is equal to 0. So when x is 0, y is 0. For my y-intercept, that's plugging in 0 into my equation. So that would be 0 over 0 squared plus 0 minus 2, 0 over -2. Y-intercept is also 0, 0. All right, so we've got a vertical asymptote at -2. The vertical asymptote at 1. I have a horizontal asymptote at 0. And I know we're touching or bouncing off of the y or x-axis there at 0. So let's test a number less than -2. So let's do n of -3. We're trying to find out, is the graph up here or is it down here? So putting in -3, I get -3. -3 squared would be 9 minus 3 minus 2. So that's -3 over 9 minus 5, which is 4, which is a negative number, so -3/4. So when we're at -3, we're negative, we're below the x-axis. All right, let's see what's happening on this side of my x-intercept. So let's try -1. I'm at -1, 1 squared would be 1, minus 1, minus 2. That'd be -1 over -2, so this is positive 1/2, which means here we're going up. And now I don't know, am I going up again on this side or am I going down over here? Again, I'm going to have to check a number. Let's say positive 1/2. I'm looking for a number between 0 and 1. So if I put in 0.5, this would be 0.5. 0.5 squared would be 0.25 minus 0.5 minus 2. So down here, this is -2.5 plus 0.25, so this is going to be a negative. Positive divided by a negative is going to be negative. So indeed, we're going down. And then last up, I'm going to find a number bigger than 1 and test it to see if my graph is up here or down here. So let's go with 2. If I plug in 2, I get 2 divided by 2 squared is 4, plus 2 minus 2. This is 2/4, which reduces down to a positive 1/2, which means we're up here. And there's our graph. Come back for video 3, and we will do example 3 on video 3. Say hi to Coach Otten, everyone.
What's up, guys?